All right, so let's take a look at all the steps involved with hypothesis testing from the beginning to the end. So you'd start by stating the claim mathematically and verbally. All right, so we're trying to interpret the claim and put it into the mathematics so we can get the hypotheses. So you identify the null and alternative hypotheses and figure out which one the claim is. Then you would specify the level of significance. Now often that's going to be specified for us, but in your own experiment you might be specifying a level of significance alpha. Now you're going to figure out which sampling distribution you're using, whether it's you're doing using Z or T, and you want to just basically make a nice little sketch just to help you understand. Then you're going to calculate the test statistic, whether it's Z or T, and the test statistic, and then the standardized value, whether it's Z or T, and then show it on that sketch, identifying which area you're talking about from the alternative hypothesis. So now this step here we have not detailed yet. That's what we're going to detail in the next two sections of how we do that. But for now, let's say there's some way you find the p-value. Right? So you find the p-value associated with that region, and then you compare it to alpha. If the p-value is less than or equal to the level of significance, which is alpha, then if it is less than, you reject the null hypothesis. If it's not less than, you fail to reject the null hypothesis. Okay. Now you know where your claim was, and so you know whether you're in a support or rejection mode, and you know the decision of whether you rejected the null hypothesis or failed to reject it. And then finally, you're going to write your interpretation in terms of the claim, of whether you either have enough evidence to reject the claim, don't have enough evidence to reject the claim, have enough evidence to support the claim, or don't have enough evidence to support the claim. One of those four interpretations. So in light of this and this idea of support versus rejection of the claim, problems can be set up in a certain way as to have an aim at supporting or rejecting a claim. So realize that again, if your claim is the null hypothesis, then you're in a rejection mode, so you could never support the claim. So if the goal is to support the claim, the setup would have to have the claim as the alternative hypothesis. Right? So that's why you would have to have the claim as the alternative. If the idea was to reject the claim, if that was the goal in this case, then you would need to have the claim as the null hypothesis. All right? Just because of the only the interpretations that we can make in each case. For example, a medical research team is investigating the benefits of a new surgical treatment. One of the claims is that the mean recovery time for patients after the new treatment is less than 96 hours. How would you write the null and alternative when you want to support the claim? And how would you do it if you wanted to, how would you interpret a decision that rejects the null hypothesis? Okay, so when I say, it can be worded in a way to choose which situation you are, basically that means of where you're going to put the equals. Okay, so to support the claim, again, if I want to support the claim, I have to be in a support mode, meaning that the claim has to be in the alternative. So this is where the claim is going to have to be. All right. So the claim, obviously the claim here is that the treatment, the mean is less than 96 hours. So that would say mu less than 96 there, mu greater than or equal to 96 there, and hence my claim is the alternative, and I get to be in the support mode. So the second question says, let's say the decision ended up being reject the null hypothesis. If you reject H0, the null hypothesis, then we're in a support mode. We rejected, the claim is the alternative. We did reject the null, bringing us to the alternative. Then we could say, then you have enough evidence to support the claim that mu is less than 96. So now let's take the same problem and try to take a different approach. So in this, let's say the end goal here was to reject the claim. If I wanted to reject the claim, if I want the end idea here to be an interpretation that has a rejection of the claim, well, I'd have to be in a rejection mode, means that my my claim has to be in my null hypothesis. So now the claim here seems to be less than 96 hours. Now what I'm going to have to do in order to have it in the null hypothesis is going to be saying mu less than or equal to 96. So it's not that we're manipulating as that the problem didn't say less than or equal to, is that the equals to case, since we're talking probabilities, isn't really that fundamental. I mean, basically we can put it in one place or the other to structure the problem in a certain way. So that would mean mu strictly less than, I'm sorry, I went the wrong way. Mu greater than 96, which is the other piece left over, would be the alternative. So how should you interpret it? So if I reject the null hypothesis, then I'm in a rejection mode. I reject the null hypothesis. Then what I'd be saying is I have enough evidence to reject the claim, because the claim was a null hypothesis and the data showed that I should reject the null hypothesis. Hence, I have enough evidence to reject the claim. So in this section, what we've done is we've set up a framework for the hypothesis test. We did everything. The only thing we did not do is find the p-value. And that's what's going to have to come next. That's what we're going to have to do. But everything else we looked at stays the same. It's just we have to find the p-value given what distribution we're looking at and what numbers we have. And we're still just going to compare that to alpha. And then everything else stays the same no matter what type of hypothesis test we're doing.